Sounds great. All right, to start off, thank you for the opportunity to present this. This is joint work with James Driver, who's going to be manning the Slack. Sounds like a sailing term or something. And Adam Kolazinski, both are at Texas A&M. And again, Tony, I think this is typically reserved for the end of the conference, but I think you deserve a lot of big credit and thanks for organizing this second of what I hear is 5 Finance in the Cloud conferences. So well done on that. So Finance in the Cloud, Part 2, Innovation Entrepreneurship. Although I have to admit, every time I see a Part 2, I'm physically incapable of not referencing changing it into, instead of Finance in the Cloud Part 2, Innovation and Entrepreneurship, changing it to Electric Boogaloo, which is referencing, of course, the classic break into Electric Boogaloo breakdancing movie. Anyway, so I have to share real quickly any opinions and conclusion expressed herein, those of ours, and they don't represent the views of the U.S. Census Bureau, especially regarding how Breakin' 2 is the greatest breakdancing sequel movie of all time. And all these results have been approved. Okay, so let's get going. So to start off in general, thinking about research, R&D, research and development. The National Science Foundation classifies research as the planned, systematic pursuit of new knowledge or understanding. And development is the systematic use of research and practical experience to produce new or significant improved goods, services, or processes. And these definitions roughly match and mix with the innovation literature's definition of exploratory innovation and exploitative innovation, March in 1991 and so 2011, among others. So exploratory, thinking about exploratory innovation is a longer horizon, exploring new ideas, riskier, whereas exploitative innovation is exploitative information is shorter horizon, building on existing ideas and safer. But theoretical predictions and empirical evidence from the existing literature suggests that ownership type should influence innovation strategy and vice versa. And there's a lot of papers, Chen et al., Ferreira et al., Gao et al., Lerner et al., really all the et als. And so there's a good literature kind of looking into this. So kind of getting into what we talk about with the title, research versus development. So due to data limitations, firm investment in exploratory research or exploitative development, it's typically only going to be measured indirectly. Now, this is what we think about this is, combining research and development spending or looking at innovation outcomes such as patents or product announcements and trying to get at whether these things are exploratory new idea patents or kind of leveraging existing idea patents. But these measures are relatively indirect. So what we've been able to do with this study is using restricted data from the Business Research Development Innovation Survey, which is called BIRDIES, conducted by the U.S. Census Bureau and National Science Foundation. We can separate research and development spending, which unlike GAP, so we can't see that generally the way firms report this, they sum these things up. It also allows us to include several other innovation and intellectual property measures that aren't typically available. And finally, and this gets to kind of a lot of the point of this paper, is to study public and private firms, which is obviously valuable when we're talking about kind of innovative spending and innovative activities. All right, so in this paper, the ownership types we're studying is first public firms, so listed on a stock exchange, and then private equity PE-backed buyout funds. So these are limited partnerships soliciting capital commitments from pension funds, endowments, rich people, and And distinct from venture capital by typically buying controlling interest in firms, changing the management team when they acquire, investing in established businesses, not startups, and using substantial debt financing. And finally, looking at these funds have holding periods of 3 to 5 years and typically have a fixed liquidation date, usually around 10 years. And then we also look at other private ownership. So this is founder or family owned, can be VC backed, but we haven't specifically looked at VC backed. I'll explain that a bit, and I'll explain why in a bit. The purpose of our study actually kind of evolved as we did get access to the data. Okay, so why do we care about buyout funds and PE? Talking about PE is non-VC. A very large chunk of if you see in this lower graph, a significant chunk of the total investment, total capital raised by fund type per year, that goes to buyouts. And the global buyout backed exit value is quite large. So we think it's an important thing to consider. Generally, and I realize I'm likely preaching to the choir here, but I think it's important to think about this in relation with our study, is the life cycle of the buyout fund. So we have the GP creates a new fund, investors commit capital to that fund, and then the GP spends time investing that capital in firms, and then having 3 to 5 years to make those investments, collecting fees along the way. Like I said, I think most people are probably pretty comfortable with this. Okay, so why, in getting kind of the purpose of this paper and what we're going to try to present some evidence about, is thinking about why ownership should matter for innovation strategy. And it comes down to horizon and incentives. And really kind of this idea is this public versus private, and how horizon incentives vary depending on these ownership structures. So public firms they could be exploiting existing ideas rather than exploring new ideas. And this could be due to a separation of ownership and management relative to private firms. This is the model of Ferreira, Manso, and Silva. So owner of a public firm can cash out equity positions. It can cash out equity positions early, while private owners can't. They suggest more development for firms, more research for private firms, and several papers, Bernstein, Gao et al., and Chen Gao et al., they've utilized patent data, and they have findings roughly consistent with this prediction. And Bernstein's paper, not exactly the same as Gao and Chen Gao, but generally finding evidence that you see more more research and more research prior to a firm being public while they're private. So public ownership, another potential route that this should matter is public ownership. It could be associated with less innovation due to disclosure costs. So public firms can be reluctant to engage in innovation. Competitors can imitate. So this would suggest that so they'll have a lower propensity for new products, a lower process innovation and research, and higher reliance on, say, development, new products, and stronger intellectual property. Okay, so and alternative to this is it could be that public firms engage in more research and development relative to private firms. Why? You have less financially, there's less financial constraints there. There's greater diversified ownership, can increase risk tolerance for failure for these kind of big picture, long horizon things. Also, related with that Ferreira work, that those kind of predictions could be resolved if, following Manso 2011, if you could effectively incentivize managers with long vesting periods and a convex payout function. So, and generally we see compensation contracts, they can exhibit variation in these sort of things. So we think this could be the case. All right. So now moving on within private, thinking about private equity versus non-private equity. So private equity ownership, they may encourage exploratory research and innovation, right? So Jensen 1989, we all know, it reduces agency problems associated with separation over ownerships and control. And it limits, back to the Ferreira model, it limits the ability of management to cash out. Consistent with some of it, so Lerner, Sorensen, and Stromberg find that firms increase patenting activity after joining a PE portfolio, and PE can alleviate some of the constraints I discussed earlier with reporting costs. Alternatively, a private equity firm might prioritize short-term gains over long-term value creation. Now there's been quite a bit of research on this that's been saying, well, no, it seems like private equity firms aren't just slashing and burning. That being said, there could be incentive to reduce exploratory and exploitative innovation. There's a recent study looking at Young and Zhang find significantly fewer product announcements for PE held firms, and take that as evidence that of kind of the short-termist outlook. But finally, kind of splitting the difference between these, given the holding period, right? It's a 3 to 5 year holding period. Private equity firms might prioritize exploitative innovation, so development, but not exploratory research. So given that focus, that medium-term focus, they're going to be focused on improving profitability in the medium term, similar to Kolazinski and Hartford, and it suggests more development rather than research relative to other private firms. Okay, so a little bit about this data. The U.S. Census Business Research Development and Innovation Survey, we use data between 2009 and 2015. Now, I know a few of you have at least some experience with birdies, but just quickly, what they do is they use a stratified probability sampling using random and probability proportional to size within stratas, and the stratas are based on whether or not they have R&D and industries within the business register. So one thing it's important to state is that Birdies does oversample larger firms and firms with R&D, and certain firms are sampled with certainty every year. And it's kind of their certainty samples a little bit weird because it varies by state. So you have the largest firms by state. That being said, these we think that this oversampling tends to allow us to kind of focus on the firms we'd actually want to. If they sample a laundromat, privately owned laundromat, they're not going to sample them again. It's going to appear once and not be on there again. There's no R&D happening there. So what we actually do, and I'll talk about this, we reduce the sample even further to allow kind of comparability between subsets. But so the Birdies contains around 1/3 of CompuStat. Selection bias due to failure of response is quite limited. Firms are legally required to respond to these things, but we do control for this in tests if they're not responding to specific questions. And from Birdies, we obtain research, development, and research and development are those things actually outlined by the NSF. R&D, well, capital expenditures specifically towards research and development, patent applications awarded, number of scientists, engineers, technicians, important trade secrets, etc. And just in general for these variables, if it's a continuous variable, we use the inverse hyperbolic sign. The nice thing about that is it's defined at 0, and so you don't have any weirdness with adding a constant like 1 to it. But with count data, we use just a natural log, or the started natural log, the 1+. So we take the Birdies data and we merge it with Census's LBD database, the longitudinal business database. This is establishment level data. has single unit and multi-unit. We aggregate multi-unit establishments. From here, we obtain payroll and employees, confirm industry. We drop firms from this private group, very, very small private firms, so whose payroll is smaller than the first percentile payroll of Birdie's firms we identify as belonging to a private equity portfolio, to allow for a better comparability. And finally, we take this after it's been merged with we merge it with CompuStat as well. I don't mention that, and we merge with Preqin database of private equity buyout transactions. We go through a pretty rigorous approach to match, and this was one of our benefits to the census, using investment entry and exit date to determine when the firm was in the PE portfolio. We name match, we manually check pairs and similarity score over 0.3. If zip codes match, if the zip codes don't match, do 0.5. Then we by hand look at these things, comparing business description, comparing address similarity, name similarity. Okay, so once we get there, first I have to kind of apologize, and we will hopefully be able to change this. This is going to be in a lot of scientific notation. It is what it is. It was the simplest way to be able to report three significant digits, three digits, non-zero digits, which we needed to do in our submission to the census for approval. So if you see 0, it's the name, but if you see -1, you have to move the decimal place over 1. So generally, the public firms are larger, and then the private firms, the PE held and other private firms. These numbers are approximations. Due to disclosure requirements, we can't give out the exact number. So there's around 11,000 firm years of public firm years, 4,500 PE held firm years, and 132,000 other private. And this is after making that cut of the 1%. So generally, we see these public firms have quite a bit more than private firms of just about everything. We'll get into some of these. We also include indicator variables. I'm not going to report them all the time when I'm showing them on the slides, but indicator variables if any data was missing, instead of just dropping it or coding it as a 0. For example, the trade secret variable, the firms are asked whether trade secrets are an important component of their business, and same thing with, say, design patents, utility patents, looking at whether they have new products are introduced or production processes. There's really a nice wealth of data here that we're quite excited about. So, okay, so getting into kind of the panel specifications here. We're going to start off testing a relation between ownership status and various innovation activities, just utilizing a linear probability model for firm year observations. Now, and I want to make clear that we believe this is largely quite descriptive, and we're measuring correlations here. But I think given some of these findings, I think it provides us some useful, interesting, stylized facts that we can look at existing theories and compare existing theories and maybe resolve some existing disagreements in the literature. So we have ownership. It could be public versus private. It could be private equity versus public. It could be private equity versus other private. We include research and development separated, R&D CapEx, trade secrets important, patents filed, patents issued, different IP, and several controls, including sales, payroll, employees, age, and age squared. And we also include 6-digit NICs by year fixed effects, and we conservatively cluster at the 4-digit NICs level. Okay, so to start off, looking at this linear probability model, and interestingly enough, we find that public firms are contrary to some of the results in the literature, are after including all after including all these controls, we have, we have a higher research for public firms. After all these controls, all these different measures, public firms have higher research and development. They also have, and I'll show them as well. We have higher R&D capex. Now, interesting is that private equity versus public, and then private equity versus other private columns 2 and 3. So now private equity, they have significantly less research, kind of consistent with this idea that of this medium-term horizon. They have consistently less research, but private equity has significantly more development than other private firms, and controlling for age within industry within these things. But we also have, they don't have any less development from public firms. In general, as I mentioned, this is providing some evidence that suggests that, well, we're seeing, given all these host of controls, we're seeing that we're not seeing less innovation at public firms. And in fact, and with private firms, we're seeing that they're not kind of slashing and burning necessarily, but just having less research, but they're having a bit more development, at least relative to other private firms, and no less development than public firms. So looking at these are the same models, just including some of the other controls. One interesting thing is we don't see any evidence that trade secrets are important for that public versus private decision. This is one thing that was, the project started off this way. We were initially going to be interested in looking at how these disclosure costs could cause firms to want to go private through private equity. We just didn't find evidence of this. But on the way to that, we discovered all of these, I think, nice, important relations. A couple other things to note. We see that design patents, so the way a product or an input or something looks, it's significantly more likely to be PE held, but utility patents are less likely to be publicly held. But public firms have more patents filed. And one thing I want to get to before moving on is, with public firms, we see that public firms have a lot more production processes and logistic processes. These are important to public firms, whereas private equity firms, we're not seeing that as much. And I think that that's going to help us to kind of explain these results relative to some of the existing literature. Okay, finally in panel B, instead of looking at research and development, we look at number of scientists, engineers, technicians, and we see the same thing. So we see the same thing. So public firms versus all others have significantly more scientists, significantly more technicians after control. Now, again, and I want to speak to this, we're not, this isn't causal, this is kind of a relationship, and I'll talk a bit more about that. Okay, so the general takeaways from table 2, right? Public firms engage in more research development relative to firms at a similar size, age, same industry, and year. It's inconsistent with the motivation of Ferreira et al., and potentially consistent with less financing constraints or more risk-tolerant shareholder base. This is quite an like I said, this is quite a new paper, but we're hoping to be able to look into these things more. PE firms engage in significantly less research than public firms and other private firms. However, they engage in more development than these firms, and no less development than public firms. And PE held firms seem to sit between public and other private. And I do want to point out, our results might appear to be at odds with Gao, Su, and Li, and Gao, Su, and Li, classifying patent language novelty and finding that public status is associated with less novel patenting. I think it's important to note that We find public firms are more likely to develop new production and logistic processes, which not as patentable. And so these research, the nice thing about being able to break out research and development is being able to look at firm investment in these things when we can't clearly see some of the outcomes, say with patent data. Okay, so next we want to move on and talk quickly about ownership associated with innovation efficiency. So regressing innovation outputs and innovation inputs, as well as 3 lags of each to control for potential lags in persistence. So doing so, and given the nature of the data, we don't have this deep balanced panel or a long section of firm years. So it reduces the sample size quite a bit. But what was it to 28,000? So what we're looking at is on the right-hand side, we have these innovation activity, these innovation outputs, and then we have the innovation inputs. What we're finding is, there we go, sorry. We're finding that we're including the lags as well as we're including deep lags to make sure we're controlling for any potential delays. We see that development and research are significantly related, at least in the first year, to these innovation outcomes. And we're not seeing quite as much with the lags. If anything, it's kind of negative. There's a reduction in this importance. One thing also to note that is consistent with kind of this learner paper is we do find that private equity firms tend to patent more. They have more patents issued. They have more patents applied for, but also consistent in kind of resolving some of this disagreement. Also consistent, we see that they also have less new products, which is consistent with this development idea. They're not developing as many new products, consistent with the Yang and Zhang finding. And finally, public, we see not as important for new production processes and service support. So looking at some of the interactions with the efficiency of innovation, we find that private equity held development seems to lead to more patents, but we don't see the same thing with research. So consistent with kind of the findings of table 2. However, with public firms, we see that both research and development lead to more patenting. Okay, so are these effects selection or causal? The nature of the study it's like I said, it's largely descriptive. It documents correlations, but to get a better sense of whether ownership type is causing innovation strategy, we examine instances where ownership type changes in our sample. And before you get too upset or excited, I know it's not the bulletproof identification, but what we do is we identify a subsample of firms with at least 3 consecutive observations that analyze the changes in variables from the year prior to the current year and the year following the current year, and we regress those changes. In innovation strategy on dummy variables, indicating a change in ownership status along with changes in controls. So what we find, not a ton. What we do find, we find some evidence, if you look in model 2, that a move from public to private equity held, there's an increase in development, and there's also an increase in support innovation, but not a lot else. And moving the opposite from private equity held to public, we do see there's an increase in product innovation and a decrease in process innovation. So generally, our takeaways here is there's some evidence there could be some actual causal changes happening from ownership to innovation, but it looks like it actually might be more selection. Okay, and finally, Tony, how am I doing on time? Do I have like 1 minute? I'm looking at my time.
Yeah,
now.
1 minute. Yeah.
Okay, awesome. So just to finish up, we look at innovative activities and seeing it, well, if it's a selection thing, it's looking at exit outcomes. Do innovation activities predict whether the firm is exited via trade sale, IPO, secondary buyout? We also did other private and bankrupt. We didn't report it due to census kind of constraints. We regressed on a system of jointly estimated linear probability models by exit type for deals exited between 2010 and 2016. What we found is that firms with higher research, more new products and services, and trade secrets were important, and patents filed, they're actually more likely to be acquired by an operating public firm, which tends to support the evidence we found that the public firms seem to be just fine with handling trade secrets, just fine with handling kind of long-term exploratory research. We don't see much in the case of IPOs. With secondary buyouts, we see kind of the opposite effects, where new products or services likely to secondary buyout. We do see it's more important when trade secrets as well, and when utility patents are important, tends to be held more privately. Okay, so just to conclude, documenting, I said very, very early evidence, but on the important differences between firm investment, exploratory research, and exploitative development. And contrary to some of the existing theories and findings, we find that public firms have a greater investment intensity in R&D, and disclosure costs don't appear to be really moving the needle here. And consistent with shorter horizons, PE firms tend to invest more in development and less in exploratory innovation. All right, thank you so much. And